Okay, so we're going to continue our notes. We drew a triangle that went through 0.86, which means that this is the x and the y. So x and y. We're going to use Pythagorean theorem to find our missing side. So 8 squared is 64 plus 36. So c squared is 100, which means the missing side is 10, right? Now the question was, find the 6 trig functions. So I'm going to find the 6 trig functions. That's the sine, cosine, tangent. We start then for sine of theta. I don't know what theta is. I don't know my angle. They didn't give me a degree. They didn't say sine of 30 or sine of 45. So we'll call it theta. That's this yellow mark. And then remember, we're going to use SOHCAHTOA. So you have so sine is OH. So of the yellow angle, opposite, you can draw yourself a line, opposite that angle is what number? 6. Okay, and the hypotenuse is what number? 10. So if you reduce that, you end up with 3/5. So sine of theta is 3/5. Should be writing it down. Let's go to cosine. Cosine of theta. The formula for cosine is adjacent over hypotenuse. And what angle am I talking about? I'm talking about the yellow angle on marked. So the adjacent is the 8, and the hypotenuse is 10. So 8 over 10. And if I reduce it, I get 4/5. Sine, cosine, what's left? Tangent of theta. Tangent of theta is opposite over adjacent. Okay, if you're going to do opposite over adjacent, what 2 numbers are you going to use? 6 and, be careful, not 6 and 10 this time, 6 and 8. Which reduces to 3/4. Okay, so that's half my answer. I wanted 6 trig functions, not 3. So now let's do the reciprocals. Remember, sine starts with an S, so its reciprocal starts with a C, so that's the cosecant. Yeah, that works too. Okay, then I'm going to flip it. Not 3/5, it's 5/3. It's reciprocal. Cosine starts with a C, so its reciprocal starts with an S, secant. Okay, and I had 4/5 as my answer, so we're going to write 5/4. You could flip 10/8, but then you're going to have to reduce it anyways. So either one, you can flip either one just to get the same answer. The reciprocal of tangent is cotangent, so instead of 3/4, it's 4/3. There's your 6 trig functions. Make sense?
Are we going to have to
Okay.
actually have to find the reciprocals then do the extra?
Find the 6 trig, hang on a second. Find the 6 trig functions. Okay, this time you're going to pass through, a point passing through 4, 4. Oops, it helped if I slid that. I'm sorry, guys. So find the 6 trig functions, but this time you're going to pass through 4, 4. Right? Here's my picture. Watch, what quadrant is 4, 4 in, you guys? Good, 1. So I'm right here, 4, 4 somewhere. It doesn't matter. But to get there, you make that same triangle like this. Right? Which means that this is 4 and this is 4. And my angle that I'm looking for is right here. What piece is missing again? The hypotenuse. So you're going to use Pythagorean theorem. To use Pythagorean theorem, I have both legs. So the formula is this. You don't have to write the formula out. You're going to get so good at it, you don't need to. But you can if you want. I've got both legs, so that's considered A and B. So A squared would be 16 plus 16 equals C squared, right? So C squared is the square is 32. Okay, now, which is perfect. He's saying the square root is 5.6. So C is the square root of 36, but we're going to leave it in radical form.
Oh, it's 36.
It is 32.
Oh, okay. Never mind.
Thank you. Okay, And we're going to leave that in radical form. What can I break that up? Remember we talked about all of our perfect squares? And I'll list them again, but they're on the board also. 1, 4, 9, 16, 25. Anything fit in yet? Which perfect square fits into 16? Not 32. I said it. 16. This is the same as 16 times 2. Right? So what is the square of 16? 4. Excellent. So C is 4 root 2. Nice and ugly. It's okay though. Right? It's alright, because that's the right answer. We'll take it. So put 4 root 2 here. Okay? Now then the directions were find the 6 trig functions. Sine, cosine, tangent. We're calling it theta because we don't know how big the angle is. All we know is it's under 90 because it's acute. It's in quadrant 1. Alright, sine, the directions for sine were opposite over hypotenuse. Okay, look carefully. They're the same, but opposite is actually this measurement right here. 4 over, what's the hypotenuse? 4 root 2. Am I allowed to have a radical in the denominator? I'm not. So I'm going to multiply the top and the bottom by root 2 so I can get rid of it. Come on guys, focus. Now be careful. Watch this. On the top, you end up with 4 root 2. On the bottom, what happens when I take root 2 and multiply by root 2? I get root 4, which drops to be what? What's the square root of 4?
2.
2. So these two together make 2. And 2 times 4 makes 8. Now, cancel. Can I cancel the 4 and the 8? Yeah, because they're both outside the radical. They have to both be outside in order to cancel. Good, which is root 2 over 2. And it's way over there, but here we go. Took a lot of work to get there, but. Yeah, how come he's saying that cosine is exactly the same? That's exactly right. It's adjacent. Cosine is adjacent over hypotenuse. Well, the adjacent opposite of the same number. So you didn't have to do any more work. Just write root 2 over 2. What's my formula for tangent? Opposite over adjacent. Which one's opposite? This is 4. Okay. Which one's adjacent? This is 4. What's 4 divided by 4? 1. That was an easy one. We made it for the hard one. Okay, now then we want the reciprocal functions. What's the reciprocal of sine cosecant? Okay, hang on, let me ask you a question. Look up here, everybody. Watch. Which one's easier to flip? The first one or the last one? They're the same. But if I flip the answer, what goes in the bottom? A radical. If I flip the first one, where's the radical going to be now? On top. So which one's easier to flip? Yeah, because then I won't have a radical in the bottom. If I flip this, a radical is going to move to the bottom and I have to get rid of it. Right, so I'm gonna flip this one. So you're going to get 4 root 2 over 4. What happens to the 4s? They're both on the outside, so they cancel and you get root 2. What's the reciprocal of cosine? No, answer the question. What's the reciprocal of cosine? Secant. And because both legs are 4, then the answer's root 2. Now move to cotangent. Well, if tangent was 1, then what's cotangent? 1 over 1 is still 1 over 1. Okay, one last thing we need to do. Did I show you guys how to convert radians to degrees? Okay, then. Pay attention. I just one I did.
You may have.
I think so.
We forgot.
Alright, here, just really quick then. We're going to convert to degrees. And let's say, for example, I have 7 pi over 6. How many degrees are there? I've got 7 pi to 6 radians, correct? Now, if you think about common sense here, if you got a unit circle, and you're at 30 degrees, by now we should know 30 degrees is how many radians? Pi over 6. Those are the same thing, aren't they? Okay? I can go 30 degrees in my unit circle, or I can go pi over 6 radians. It's the same. Well, if I'm going to convert this one, times 70, that's right, good job. Okay, this is all in the unit circle, but if you want to show you, if you're converting to degrees, then you can multiply, start with degrees. How many degrees are in a circle? 360 out of how many? 2 pi. Right? Now, with your calculator, what's going to take 7 times 360? So on your calculator,
Did you just do 30 times?
yes, you can do it 1,000 ways. So if you do 7 times 360, you get 2520 pi on top. On the bottom, you get 12 pi. There's 1,000 ways, guys. Okay, what's going to happen to the pi's? They cancel. And then, now, if you don't know this cool trick, watch. You can do 2520 divided by 12 and do math, enter, enter. And what happens to the fraction? It will reduce it, right? So the answer is just 210 degrees.
But if you know the degrees and you know.
Yeah, if it's on the unit circle, you can use that trick. If it's not on the unit circle, it won't work.
Okay.
Okay. Now, try another one. That way only works if it's on the unit circle, so you might as well write down my way. Convert to degrees. Because I'm telling you to convert to degrees, start your equation with degrees. See how I highlighted the word degrees? So start with degrees on top. Okay, on your calculator, if you want to, there's 1,000 ways to do this. I'm just going to do 360 times 5, and you end up with 1,800 pi. 3 times 2 is 6, you get 6 pi. So those cancel, and then your final answer is how much? 300 degrees?
6 divided by 12.
Should be 6.
Oh, you were. Oh, okay.
I
You were
thought.
talking about for the last problem.
Yeah. Okay, now we're going to go the other way. Convert to radians. We're going to convert to radians. Notice, I convert to radians, which means we're going to start with radians. So for your first example, if I say 120 degrees,
You start with radians.
just like we did before, like look, when I say convert to degrees, we put degrees on top.
Oh, okay. Oh,
Right? I guess I'm saying it wrong. When I convert to radians, I want to put radians on top to help you remember. Now guys, 120 is on the unit circle. If you look at your unit circle, the answer, let's see if I have the unit circle that'll fit on here. Here's 120 degrees. There it is. How many radians is it, guys? 2 over 3. But when I'm giving you these problems, they won't all be pretty like that. Okay? So if I want to convert to radians, I put radians on top. That's what I was trying to show you. So put 120 over 1. Now then you just simplify. 240 pi over 360. And this is where kids get stuck. Okay? They try to put pi in their calculator. We don't want to put pi in our calculator. Doesn't radians have pi in it? Right? So that it's perfect. So ignore the fact that the pi is there. In your calculator, just reduce by taking, there's a shortcut if you want, 240 divided by 360.
Can't do that.
240 divided by 360, and then hit math, enter, enter. And it reduces your fraction. Math, enter, enter. So you get 2/3, which is the same as 2 pi over 3, which was what we said it was. You try one last one. What about 150? It's on the unit circle, I realize that. I'm just trying to show you the method. Convert 150 to radians. If you're converting to radians, radian goes in the numerator. So times Your calculator can do 300 divided by 360. Math, enter. And you end up with 5 pi over 6. Okay, last but not least, we have one last thing. If you don't have a calculator, you're going to need it now. This is going to say express in, and we'll use DMS, which is the same as degrees, minutes, and seconds. Right, now let me talk to you about something really quick. I just showed you 150 degrees. So on my unit circle, this might be a 150 degree angle, right? So we can call it 150 degrees. We can call it 5 pi over 6 radians, correct? And that, both that stop right there is called 150 degrees or 5 pi to 6 radians. Now here's my problem. On a unit circle, what if I wanted to go, for example, right here, this angle? And if this is 90, and I want to go between 90 and 89. Is there anything between 89 and 90 on the number line?
Yes.
Absolutely. So do you think there's anything between 89 and 90 degrees in a circle? Heck yeah. If you're flying an airplane and you want to go a certain degrees from due north, okay, do you think you want to be limited to being able to only go 91 degrees? No. 91 degrees over the entire planet is between 90 and 91 is a big difference, correct? So that's what I'm about to show you. I'm about to show you how to get between 2 degrees, right? So for example, they call it degrees, minutes, and seconds. So if I'm asking for you, if I'm telling you guys, I want to go 40.91 degrees. That's between 40 and 41, right? Well, the other way they call it, instead of writing it in a decimal form, they put it in degrees, minutes, and seconds. You're either, if you're between 2 whole numbers, you're either in a decimal, okay, focus with me so you can make a connection. You're either in a decimal or you're in a degrees, minutes, and seconds situation. So we're in a what kind of situation here? Decimal. Right. It's okay. So we're going to convert it. So take your calculator. This is so easy. Your calculator will do it for you. So if you turn your calculator on, type in 40.91. Alright? Then, on your calculator, you're going to do second apps. That's the purple key, guys. It's next to the math key. Go to second apps. Okay, and what do we want to turn it into? Do you see it in there? DMS. So go down to DMS and hit enter. I went to second apps. Now go down to DMS, hit enter, and enter one more time, and there it is. So what that means, write yourself a little note on where you went. You went to second apps, and you typed in DMS, which means you're 40 degrees, 54 minutes, and 36 seconds. That's what they call it. Degrees, minutes, and seconds. That's the answer. Now you try one. What if I told you you're at 180.2 degrees? That's in decimal form. 182. Go to second apps, 180.2, second apps, and you should get, I want it in DMS, so I want degrees, minutes, and seconds. I got no seconds on that one, right?
Do you have to put seconds?
Mm-hmm. Yeah, put it all.
Oh, 180.3.
Now you're going to go the other way. I'm going to give you degrees, minutes, and seconds, and what are you going to turn it into? A decimal. Okay? So here we go. Express in decimal degree. Write the directions. Okay, you're gonna express it in degrees. Let me show you how to do it. You do the same thing. You go to second apps again. Okay, so type in the 15. Go to second apps. Did you see the degree symbol? Is it number 1? You'll see it. Type in the 15 only. I typed in the 15. There's my degree. I'm going to hit enter. So now I've got 15 degrees. What's next? 18 minutes. So there's my 18. Go back to second apps again, and there's my minute symbol. Hit enter. Now go to 12. But you'll notice when you go to second apps, is it there? It's not there. So instead, no. Look above the plus symbol. Do you see the seconds above the plus symbol? It's down here. Here's the plus symbol, and you'll see the little 2 marks. What color are they? Green. So you go to alpha plus. That's in degrees, minutes, and seconds. We want to turn it into a decimal, so just hit enter. 15.3. Okay, the next example, try it. 13 degrees, 14 minutes, and 4 seconds. Don't forget that the seconds, you have to hit alpha plus. So write yourself a note. 4 seconds, use alpha plus. When you do that, you should get 13.23 degrees.